All right, so in this lesson, we're going to learn how to use Cramer's rule to take a system of equations, then put it, and then use matrices to solve a system. So that's what Cramer's rule does. It takes a system of equations and uses determinants to find the solution. So let's quickly review how to solve a system of equations without Cramer's rule, just algebraically. So you probably learned three ways. You probably learned by graphing, by elimination, and by substitution. For this specific example, elimination is probably your best bet because to graph both these lines is manageable. It's just, they're not in any special form other than standard form. And to find where they intersect probably takes some time. Substitution is better when you have a coefficient of 1, but none of these have coefficients of 1. They have 4, 5, 3, and 9. So elimination is what I'm going to use here. So if we look at our first coefficients in front of x, we could try to get opposites by multiplying everything in the top equation by 4. So we get 12x plus 20y equals 28. And then if you look at the bottom equation, to get an opposite coefficient, I'll multiply everything by -3. So we get negative 12x minus 27y minus 33. All right, so all math that could be done without a calculator. Now, another way you can solve a system is if you have a TI-inspired CAS, you can solve it that way by plugging it into your calculator. So that's cool if you have one of those. All right, but now we're going to add these two equations together. So, since negative 33 is equal to negative 27, that should be an x, not a y, minus 27y, it's like you're adding the same thing to both sides of an equation. So when we add these two equations, these will cancel out because it's 12x minus 12x. And then 20y minus 27y would be negative 7y. And then 28 over negative 33 would be, if you add those two together, would be negative 5. So we get y is equal to 5/7. All right. Then you could plug that back in and find the x coordinate. So for that, I'm going to use my calculator because fractions, they're annoying. So we got to figure out how to stop writing here. So now we know that y is equal to 5/7. So we could do like 3x plus 5 times 5/7 equals 7. So I got y was 5/7, so I plugged in 5/7 for y for the top equation. All right, so then I could subtract 3 times 5/7 on both sides. So I can erase it here. Right, and then you get 3x is equal to 24 over 7. So divide both sides by 3. So 24 over 7 divided by 3 would be 8/7. Right? So x is 8/7, y is 5/7. Right? We could check our work by putting it back in. So if you take like the bottom equation now and then plug in 8/7 in for x and then plug in 5/7 in for y, all right, really easy to check on a calculator, we get 11. All right, so nice, we did that. Now we're going to solve the same system but using determinants, all right? And whoever wrote this, not me, is really excited about that because they typed in all caps. I don't know why they're yelling, but they're super excited. And you might be thinking, why the heck do we have to do this? We just solved the system algebraically. Isn't that good enough? And yes, if your only goal was to solve a system of equations, then yeah, don't do this. But it's cool to see how you can use matrices in other situations. And this is one that you've learned before. So it makes sense to do this. All right. So now, how do you solve a system using determinants? All right. For a system of two equations, you need to find 3 determinants. One is called d, one's called dx, and one called dy. All right, and we're going to divide those, but we'll do that later. So d is just your coefficient matrix. So if you look at the system of equations here, okay, the coefficients are like 3 and 5 for the top equation and 4 and 9 for the bottom equation. So d is just going to be the determinant of a matrix where like the first row is 3 and 5 and the second row is 4 and 9. And D represents the determinant of that matrix. So this is something we could do by hand. 27 minus 20 equals 7. Okay. Now dx means you take D, the determinant of this coefficient matrix, and remember, like this column were the coefficients in front of x, and this column were the coefficients in front of y. So dx means you replace x, so you replace that column with the constants, like with that answer. So like 7, 11 go into this first column now. And now we're going to find the determinant of that. So remember, this came out to be 7. All right, this will come out to be 63 minus 55, and that's 8. All right, and then dy is when you take your coefficient matrix, but replace the y numbers with the constants, or the numbers on the other side of the equation. So that's how we get that right there. Now find that determinant. So that's going to be 3 times 11, which is 33, minus 4 times 7, 28, and we get 5. Now, these numbers should look familiar, or you have terrible short-term memory. Why they look familiar? Well, 7, 8, and 5. Well, if you remember, when we solved this equation here up top, which is the same one here, we just solved it a different way, we got that x was 8/7 and y was 5/7. All right, and if you look at the determinants we got, all right, x is going to be dx over d, and y is going to be dy over d. All right, and that's Cramer's rule. Now for a 2x2, it might be easier to do elimination, but it might also be easier for you to do it this way, because really there wasn't that much work we did. We did some multiplying, some subtracting, and then some easy division where we put one number over another. All right, so that's it. So our answer for x is going to be dx over d, which was 5/7, I think. I don't remember now. Now I have bad short-term memory. 8/7 for x, and y was 5/7. So we do dx over d for x and dy over y for y. So we want to add that part right here. All right, x is equal to dx over d, and dx is the determinant of the matrix where the first column are the answers and the second column is y. All right, and y is going to be dy over d. All right, so let's try another one. So for this one, first we got to find our determinant of just the coefficient matrix. So we'll call that D. So this is already in standard form, so you don't have to like add or subtract anything. So the first column is going to be like 5 and -7, and then the next column is going to be -2 and 3. All right, and then we can find that number, and that comes out to be 15 minus 14, so that's 1. So that's nice. D is 1, so we'll be dividing by 1. Now dx, you take the same matrix that we got for D, but we're going to replace our column of x coefficients with the constants. So -9, 14 in the first row column, sorry, but that second column is still going to be -2 and 3. So it's just like this matrix, we just replace x with these numbers. All right, so find that determinant. So that's going to be -27 minus -28, which is just equal to 1, because a negative minus a negative is like adding. So -27 plus 28 is equal to 1. All right, so we can actually find x. We know that x is just dx over d. So x is going to be 1 over 1. So x is 1. Nice. So at this point, we could just plug 1 in for x and solve for y. But if we wanted to, use Cramer's rule throughout the whole question, which I may ask you to do, then for this one, we're going to take the same matrix that we had for D, but we're going to replace the y's with the constants. So the first column is going to be the coefficients in front of x, just like D. But then the coefficients in front of the next column, we replace these numbers here with these numbers. So we'll put a -9 and a 14 there. Okay, now cross multiply. So 5 times 14 is 70 minus 63. And we get 7. So our final answer, all right, x is going to be dx over d, so 1 over 1, and that's just 1. And y is going to be dy over d, so 7 over 1, 7. All right, and then when in doubt, or not even in doubt, always a good strategy, like plug your work back in. So 5 times 1 is 5, minus 2 times 7 is -9, so that works. And then if we plug in 1 and 7 into the other equation, we get -7 plus 14 plus 21, which is 14. So our answer checks out. Cool. Any questions? That's Cramer's rule. People like it because it's, compared to some of the things we do, it's not that bad. It's pretty straightforward. And it's pretty interesting. All right, so I had originally intended to put you in breakout groups, and then you each take a determinant and then put it together, and that would be cool. But I just, something inside of me, I don't have a good reason. Let me just show you how to do this with the calculator instead, and then I'll let you guys go. So I'll save you the breakout rooms. So for this one, we could do it by hand. I believe I did show you how to find a 3x3 by hand, and I don't know when you'll ever need to do that, but for anything bigger than a 2x2, I'm fine with you using a calculator to find the determinant. So let's do this together, and if I'm going too fast, just stop me. And if you don't have a TI Inspire and you need help with doing this on your calculator, just hang back after class and I'll show you, or I'll talk you through it. So to solve this system of equations here using Cramer's rule, first we have to find D. So D is going to be the determinant of the coefficient matrix. So on a TI Inspire, for determinant, the best way to do it is just to type in like DET, open parentheses. Okay. Now, you could also hit menu, matrix, determinant, and you accomplish the same thing. So you more of a pointer or a typer, it's up to you. Now, inside that parentheses, we need to put the 3x3 matrix that we want to find the determinant of. So if we're doing D, right, that's going to be the coefficient matrix. So we're going to insert a 3x3 matrix by hitting this number next to the 9, and then looking for the 3x3 matrix template. All right, we want a 3x3. So the first row is going to be 3, -1, 2, because 3 is the coefficient in front of x, -1 is in front of y, 2 is in front of z. Now you actually could have ordered that any way you wanted, but you have to remain consistent after that. So if 3 is the coefficient in front of x in the top row, then for the second equation, you should put a 2 here because that's the coefficient in front of x. And if -1 is the coefficient in front of y, then the middle column should be coefficient in front of y. And each row should represent the same equation. So this would be 2, 3, -1. And the bottom row would be 7, -4, 3. All right, and just be careful. Sometimes me or someone slick will like switch these two around. So make sure that it's in standard form, meaning it goes x, y, z, x, y, z, x, y, z. All right. So hit enter and you'll get the determinant. -30. All right, cool. So D is -30. Oops, you're not going to see that because that's black on black. -30. Okay, now for dx. So let me show you a cheat code for the calculator. All right, cheat code is copy and paste. So I'm sure I've shown you this before, but maybe you forgot, or maybe I didn't. But all you have to do is arrow up to highlight something. And if something's highlighted and you hit enter, it'll copy and paste that. And when you copy and paste something, you can then edit this. So remember, our dx is just like the coefficient matrix, but the column of x coefficients, like this one that goes 3, 2, 7, is to be replaced with the constants, like what each equation equals. So 4, 14, and negative 4. All right, hit enter, and we get d of x is negative 30 as well. So I know that x is going to be negative 1 because dx over d is equal to x. Oh, sorry, positive 1 because negative 30 over negative 30 is positive 1. So x is going to end up being 1. And we'll come back to that later. All right, now, for dy, make sure we're going to copy and paste the matrix again, but make sure you copy and paste the top one because you don't want to copy and paste this one and then replace like this row because then you also have to replace this first column. So go back to the original thing we typed in. dy is the coefficient matrix, but you replace the y column with the constants, with 4, 14, and negative 4. Right, we get negative 150. So y is negative 150, which means that, or dy is negative 150, which means that y is going to be 5 because y is equal to dy over d. All right, and then for dz, we want to go back to the original determinant matrix, copy and paste that. So that's the coefficient matrix. But for dz, replace the z column with 4, 14, and negative 4. And then we get negative 90. Now, it doesn't mean, like, your answer shouldn't always come out as whole numbers, but if you get whole numbers, that probably means you're doing something right. And if you don't get whole numbers, it doesn't necessarily mean you're doing something wrong, but could be. All right, so now, to find x is dx over b. So x will be negative 1. Y is dy over d. Y is 5. And z is dz over d. Negative 90 over negative 30. All right, so I think I typed this in wrong here too. So my bad. It should be dx over d. So that would be negative 30 over negative 30. All right, so x is 1, y is 5, and z is 3. And always good to plug your answers back in, see if it makes sense. And if you have a TI Inspire, you could actually, it actually doesn't have to even be a CAS. You could solve a system of any linear equations. And then type it in, 3x minus y plus 2z equals 4. All right, so this is something you should do if you're taking like standardized tests and you're allowed to use a calculator and you have a system. Like let the calculator solve it. Any like word problem where you take the word problem and put it into an equation and then it comes out to be a system of equations. Oh, what did I do? 3x, y, 2z equals 4. 2x, 3y minus z equals 14. 7x, 4y. Oh, I see. The last step always gets me. Boom. All right, so we just checked our work, 1, 5, and 3. So that's all. So if you didn't know how to do that, linear solve, that's good to know. And if you need me to do that again slower, just let me know. All right, so that is Cramer's rule. I'm going to pause this. I didn't even record anyway. Oh,